Hello everyone. Welcome to our presentation on separation of mixtures using different techniques. This is a presentation by Elliot, Matthew, and Raja. First up, we have hand separation. Hand separation is a crude method of separation. It can only be used to separate solids. Basically, we're exploiting some of the physical properties to separate. An example is a mixture of salt and sand, and someone is manually picking the salt out grain by grain. This does not change the chemical composition of the sand. As this is a very crude method, it should not be used unless it is the only possible method. There are some other examples on the screen. Next up, we have evaporation. When a liquid reaches its boiling point, it begins to evaporate. If all of the liquid evaporates, you will be left with only the solid remaining. This is a common occurrence in everyday life. It is a major component of the water cycle. This method is ideal when you have a liquid and a solid. This is very common also because almost everyone has access to a source of increased temperature, such as a stovetop, and can be done without too much work. An example of evaporation is when you heat salt water to a boiling point. You are left with salt in the pot. Okay, so next up we have filtration, a method which involves the use of a medium. So in the case of the diagram here, an example of the medium is that filter paper. The medium allows the fluid portion to flow through while stopping the solid portion of the substance. Also, this differs from sieving, as sieving only contains one medium, while filtration uses more than one medium. An example of filtration is renal filtration, which is removing waste from blood. There's also sewage filtration, which is pretty self-explanatory. This should be used when separating small solids from a liquid. For example, a coffee filter. It separates coffee grounds from water. Alright, so next up is distillation, the process of separating liquids through selective evaporation and condensation. Evaporation is when liquids go into a gaseous phase, and condensation is the opposite. It is used heavily in food processing and high alcohol content drink processing. It's done through a still. It should be used when substances need to be separated to a greater degree than other methods. An example is when crude oil is heated up. Certain liquids start to boil at different points, and usually when the boiler reaches that boiling point, it will hold that temperature until all of that liquid is done and it is ready to separate the next fuel. This gas that we've now created goes through a condenser and is collected. This process is way more complicated, but that is just a brief overview on how it works. Alright, so next up is recrystallization. An impure substance is dissolved into a boiling solvent. The impure substance must be soluble. Afterwards, the substance is cooled, first by air, then by ice. At this point, the impure substance should crystallize before the impurities. This is assuming there was more impure substance than impurities, thus resulting in a pure crystallized end substance. A filtration method must then be used to separate the crystallized and more pure substance. This method can be used multiple times to purify further. It should be used when an impure object is needed to be purified. Substances will usually become more soluble when the solvent is hot than when it's cold. Therefore, a compound may dissolve in a warm liquid but be insoluble at room temperature. For example, sugar dissolves better in warm water than in cold water. Alright, so now we have solvent extraction, a method in which a polar solvent and a non-polar solvent are added to the target compound, usually two liquids. Each solvent dissolves a different part of the compound. When each phase is separated, the solvents evaporate, leaving the different parts of the compound clearly and cleanly separated. This method should be used when you have smaller amounts of liquids and access to the required solvents. You put both liquids in a separatory funnel and use this to extract only one liquid at a time. So an example for this would be that solvent extraction is used when in the refining process of uranium for nuclear reactors. And you can see the diagram below as well. Alright, so last on our list is gravity separation. So if you hold something heavy in one hand and whirl your arm around your head, you'll feel a force that seems to be pulling your shoulder out of its socket. This is the law of inertia. Stuff likes to go in a straight line. A washing machine is a good example where the water is pushed out in centripetal force, but the clothes keep spinning and get dry. In a centrifuge, the denser particles are pushed out to the side and the less dense particles are displaced towards the center. If something can go in a straight line, it prefers to do this, and this way the water particles from the clothes are separated from the actual clothes. Alright, so that has been our presentation today, and I hope you enjoyed. Thanks for watching.